Thank everyone for joining us. I'm Lee Schober, Senior Preservation Services Manager here at Historic New England, and I'm joined with Carissa, our team leader of Preservation Services, and she will be talking to us tonight about energy efficiency and your old home. But before we kick it off, I just want to give a little introduction to Historic New England and who we are and the work that we do. So Historic New England, previously known as the Society of Preservation of New England Antiquities, is the largest, oldest, and most comprehensive regional heritage organization in the country. As part of our mission, Historic New England saves and shares homes, open space, collections, stories from the past to today. And so through our collection, archives, events, and our 37 historic properties, we offer a wide variety of authentic ways to experience the lives and stories of New Englanders. Next slide. But our preservation reach isn't limited to our collections and properties. Carissa and I are both part of Historic New England's Preservation Services team, and our work focuses on building partnerships and with preservation-minded people outside of the organization, with a shared goal of preserving and protecting properties throughout the region. We achieve this through legal protections like preservation easements and our easement program, through preservation education opportunities like tonight's lecture for homeowners, strategic advocacy for historic resources, and our Homeowner Services program. Next slide. So something that might be interest to all of you is our Homeowner Services program. This is a unique member benefit that gives you access to advice for when you research, paint, repair your old home. So if you have more questions that go beyond tonight's lecture, benefit, you can find out more information on our website. Appleton, who founded Historic New England in 1910. Appleton's work emphasized key tenets of preservation that still guides today's preservation work, such as respect for change over time, documentation, and in-kind material replacement. Next slide. And while Historic New England's goals as a property owner are a little bit different than the typical homeowner, part of our mission is to share our preservation knowledge with the public. So I'd like to, I'm going to hand it over to Carissa, who will share with us sensitive strategies to help increase energy efficiency in your old home.
Thank you, Lee. And hi, everybody. Thank you for joining us tonight from all over the region and really all over the country. It's great to have so many people together for this talk tonight. As an organization that has spent over a century advocating for preservation of historic places, we know it's really important to show that older homes can be adapted to modern needs in ways that are affordable, effective, and sensitive to their historic value. And one key aspect of that is to increase their energy efficiency. Making older homes more energy efficient is a really big topic, frankly. So we're going to start tonight looking at the big picture, why energy efficiency in older buildings matters. And then I'm going to walk you through some simple things that you can do as homeowners or renters and give you tools so that you can weigh the pros and cons of common retrofits based on your home and your goals. And finally, I'm going to end with a case study of how we actually did some of this work at our property, the Lyman estate. So starting with that big picture, there are three big things that I really want you to understand when it comes to energy efficiency and older homes. First, old houses are not the biggest problem when it comes to energy efficiency. Energy efficiency is also not a new concept, and there is no one-size-fits-all approach when it comes to making a home more energy efficient. So we all know that being efficient energy consumers is important at a global scale. And this chart shows data from the National Energy Information Administration. This is basically how the United States uses energy. And you can see from this graph that the building sector accounts for about 33% of US energy consumption. Residential buildings specifically account for about 18% of our energy usage. But old houses are not a big contributor to that 18%. The National Register of Historic Places is the nation's official list of buildings, sites, structures, objects, and districts that are worthy of preservation. And it requires a property to be at least 50 years old, with some rare exceptions, before it's considered even potentially historically or architecturally significant. So old in National Register terms means a building built before 1970. And according to the US Census, 77% of our country's 140 million housing units were built after 1969, after that point. So in National Register terms, that means only about 4% of our national energy usage is by old houses. And in case you don't think that 50 years is old, only about 12% of houses across the country are 80 years old or older. That's 17.2 million really old houses that account for about 2% of total US energy consumption. So old houses are not the biggest problem when it comes to energy consumption, and knocking them down for new ultra-efficient construction won't solve our global energy issues or our climate crisis. That said, we're really lucky because in New England, we have a lot of these old houses. Between 21 and 31% of our housing stock was built prior to World War II. So it's worth thinking about how we as a region can increase the efficiency of old houses. And aside from any larger impacts, it could actually save you some money, and it could just plain make you more comfortable in your home. And a little extra information for you Massachusetts residents, since I know there are several of you in the audience tonight. The standard for energy conservation in new construction and remodeling is a HERS, Home Energy Rating System, level of 100. And HERS is a scoring system to rate energy conservation based on a blower door test, a duct compression, or a leakiness test, and other measures of home energy use. Massachusetts provides incentives to communities to set local standards that are below the 100 HERS level at 85 HERS, called the stretch code, which is the level required for Energy Star new homes. And what that means is that if you live in a community that has adopted the stretch code and you're doing renovation work on an older home, the elements being changed are required to meet stretch code standards. There are only exceptions if your house is listed or determined eligible for listing on the National Register of Historic Places. So in 2009, the city of Cambridge put the stretch code to the test by rehabbing a typical three-decker to meet the code's energy conservation standards. So that three-decker had an initial HERS rating of 143, and they brought it down to an 85 through a few things: the addition of R13 wall insulation, R30 ceiling insulation, and comprehensive air sealing. The energy upgrades to meet the stretch code added just under $15,000 to the overall costs of the building rehab, and they reduced the annual energy consumption costs by about $2,700. So basically, that study proves that old houses can meet stringent new standards at a fairly reasonable cost. And this is really good news for those of us in the preservation field who think that older homes are worth keeping around, because it underlines the point that we don't need to demolish all the great old houses that we love here in New England just to meet new energy codes. And improving the efficiency of New England houses isn't a new idea. Chopping wood and shoveling coal are really hard work. So people have been pursuing ways to reduce their energy consumption for as long as houses were being built. Early New England homes faced south to take advantage of the sun. Brick nogging and eelgrass were used as insulating materials. Ceilings were kept low to keep heat closer to occupants. Shutters kept out hot sun in the day and kept warm air in at night. And in the 19th century, double hung sash allowed for better air circulation. You open the top and the bottom a little bit to create a kind of convection current in the summer. Later, casement windows actually allowed even more airflow. Likewise, radiators were positioned beneath windows to create convection airflow in the wintertime. Sash locks were used to keep windows tightly closed and to seal out drafts. Heavy drapes and rugs insulated, and doors could be closed to keep in the heat. Porches shielded windows from high summer sun and allowed people to live outside in the warm weather. So you can see this has been going on for a long time. Today, energy efficiency is a really big industry, and starting a weatherization project can be kind of overwhelming. The home improvement industry would be very happy to help you make your house greener. Home Depot, Mass Save, the Department of Energy, there are all kinds of places to get information and to buy things, but not all of these resources have historic preservation or old buildings in mind. For comprehensive information on home energy savings, I tend to think that energy.gov is really the best place to start to educate yourself about some of these matters. Now, old houses have a cultural memory value, but from an energy standpoint, an existing house also has value for its embodied energy. That's the sunk cost of material and labor that were used to create the building in the first place. So keep in mind, as you think about energy efficiency in your house, that a lot of businesses are trying to make money by selling you new products. But in order to be an efficient energy consumer, you don't want to waste the embodied energy that you already have. In other words, maintain your old house. It's the ultimate recycling. And when you're thinking of buying something new to make it more efficient, keep in mind the energy that is wasted when we choose replacement over maintenance, when we throw away serviceable materials, and when we manufacture, ship, and install new products. And that brings me to the last point in this kind of big picture part of the presentation. In an old house, a one-size-fits-all approach to energy retrofits isn't going to work. But there are some best practices to keep in mind. Keep your interventions simple and reversible. The corollary to that is avoid overly complex and costly solutions, and treat your old house gently. It's irreplaceable. Focus your more invasive interventions on new additions or on a new house. Old houses can absolutely be made more efficient, but we have to consider the house, its age, its use, and what systems are in place now for windows, heating and ventilating, and insulation. And every house is going to require a little bit different approach to weatherizing. So that brings me to kind of part 2 of our roadmap for tonight, what you can do. So while you want to be thoughtful about changes to old houses, there's still a whole lot that can and should be done for any house, regardless of its age or its historic significance, in order to make it less of an energy consumer. Start by taking advantage of those historic energy efficiency measures. Use your sash locks, close your blinds and your drapes. Also think about your habits and expectations. Rather than heating your whole house to 70 degrees, put on a sweater. Next, consider the simplest interventions. Many simple things can be done by you for relatively little money or by specialists at a fairly reasonable cost. Using energy efficient light bulbs and programmable thermostats are an easy way to start. This low-hanging fruit gives you the best return on your investment in terms of energy savings. And those more expensive, more invasive solutions are going to be wasted if you don't do some of these simple fixes in the first place. And that means considering things like air sealing, windows, insulation, and heating and cooling systems. So a great way to decide how to get the most bang for your buck is with an energy audit. And this is a test, basically, of how leaky or drafty your house really is, where the issues are. An energy audit uses a blower door with a fan to generate a positive or negative pressure that directs air in or out of the home. And then you can test the logical entry points for leakage. Sometimes you can actually feel the air moving with your hand. But a lot of qualified energy auditors are going to use either a smoke puffer, so you can see the smoke move, or some of them will even use an infrared camera, which is what you're seeing on this slide here, that picture with the orange and purple. That's going to show you where cold air is leaking into your nice warm house. So this graphic shows the kind of places you typically find air infiltration. And once you know where the sources of infiltration are in your house, you can fill them. And the fancy term for that is air sealing. Air sealing is an obvious improvement in preventing winter drafts, but it's also really useful if you have air conditioning going in the summer. Wood windows are much maligned as a source of drafts, but if you are among the lucky folks who still have your old windows, keep them, keep them, keep them. Unlike vinyl, they are built to be repaired, so they can last and last. Wood windows do need maintenance. That's things like paint and new glazing putty, sometimes some carpentry repairs or general tightening up. And you can enhance their energy efficiency with weather stripping and consider adding a storm window. So there are lots of studies now that show that a well-maintained wood window plus a snug-fitting storm window is basically as efficient as a double-glazed vinyl replacement. And you can get exterior storms or interior storms. There are pros and cons to both. For exterior, they are going to provide a good air seal. They're going to protect your historic sash from the weather outside. And they don't have any major impact on the interior view of your windows. They can also obscure your historic window from the outside, and so you have to think about the impacts of the aesthetics of an exterior storm. They can also be more challenging to install or to take down. You have to get on a ladder if you've got second-story storms. For interior storms, they're also able to provide a very good air seal. They don't have any of that visual impact from the outside. And they can virtually disappear on the inside. You're looking at interior storms on that picture on the upper right of the screen. So they also, they have some cons. So they don't provide the same weather protection that an exterior storm would. Of course, then you have to take them in and out seasonally if you want screens in your window. So you have to find room to store them. The decision for a lot of homeowners relates to ease of use with storm windows and what you choose. And it has a lot to do with whether you want to change them out seasonally. So as with all energy efficiency upgrades, start insulation with the easiest projects first. It's relatively easy to insulate hot water pipes, your hot water heater, and to seal and insulate ducts and cold air returns in the basement and the attic. Next, think about unfinished spaces that you don't need to heat or cool. The attic is a great place to insulate. It can usually be done without being overly costly or invasive in terms of historic fabric. Watch out for heat sources, chimneys, vent fan housings, recessed lighting, that kind of thing. Gaps around those elements should absolutely be sealed. Otherwise, a lot of the value of the insulation will be lost. Bats can be used in attics, rolled into kind of regularly spaced openings. Rigid foam can be cut to fit. And if you don't want to take up the entire attic floor, or if you have uneven cavities, then dense packed cellulose can be blown into those spaces. Insulating your basement is a little bit more complicated because very often the heating plant is down there, and there's generally also bigger moisture issues in basements. The most valuable area to insulate is at the sill or the rim joist and around any penetrations, things like utility connections coming into the house or ducts going out of the house. What about insulating the walls of finished rooms? When we did an energy audit of one of our oldest properties, the 17th century Pierce House in the Dorchester neighborhood of Boston, we found that only 30% of our envelope heat loss was through the exterior walls. 70% of the loss was from more controllable locations like air leaks, the windows, and the uninsulated attic. there's that pesky goat again. Whatever you may be told, know that introducing insulation into the walls of an old house is complicated. If you have active older wiring in walls that are retrofitted with insulation, that can be a potential fire hazard. And there are also potential moisture issues that come with wall cavity insulation. So a colleague spotted this Greek Revival house in Connecticut several years ago. Whatever wall insulation was added to this house, it is now harboring so much moisture that the entire framing structure of the house can be read in the mildew patterns on the outside walls. This is what preservationists fear when we say don't insulate your wall cavities. This is probably a 1970s oil crisis insulation job run amok, and 40 years later, the house is well on the way to ruin, and the interior is very likely rather unhealthy for the occupants. Poorly done wall insulation is also the culprit at these buildings where paint is sheeting off the walls that are insulated. These days, blown in or dense pack wall insulation done properly doesn't have to result in these kinds of moisture problems. But managing moisture in houses where you're breathing and cooking and showering is a really complicated piece of building science. It's easier to do it when you have full access to the wall cavities, but for most historic houses, that involves removing all of the clapboards and the sheathing, or all of the plaster and woodwork on the interior. And at that point, you really just have to consider whether it's worth it. Spray foam is a newer technology that is also advertised widely for insulation. It's a really good insulator, and it also very effectively seals gaps as an air sealing measure. And it doesn't absorb moisture the way that kind of 1970s insulation could. But before you invest in it, there are a number of things to think about. So it can't be blown into small penetrations. That means in finished spaces, you would be, again, having to remove the entire interior wall surface to install this. It may require mechanical ventilation to maintain the air quality inside your home. And spray foam off gases when it's installed, and it can release some pretty toxic fumes if you ever have a house fire. Spray foam also hides what's beneath it. So yes, there's a potential aesthetic consideration with this, but there's also potential problems in diagnosing future issues. For instance, if you spray foam your attic and then you develop a leak, you're probably not going to see it until it's done quite a bit of damage. And even then, it's going to be difficult to figure out exactly where that leak is coming from. And finally, spray foam is not easily removed. When it's in, and you're looking at a major effort to ever remove it if you want to. So those are some big downsides to compare with how much these insulation strategies are really going to decrease your overall energy consumption. And this gets to a bigger point. If you get advice from a contractor that doesn't seem quite right to you, get a second opinion. It's just like going to the doctor, right? You wouldn't go in to have a major operation with misgivings about the advice or the diagnosis that you've gotten. Many contractors are very well intentioned, but they are out there only knowing about a certain type of construction, new construction, and they're not necessarily able to give you the best advice for your old house. Shifting gears a little bit here, solar is another relatively new technology that has been the subject of great debate in preservation circles. I am not an expert on the economic pros and cons of photovoltaic or solar hot water systems. But if you decide that solar makes economic sense, the next step is to have a structural engineer determine if your roof can actually support the installation. The weight of solar panels is not insignificant, and it may require you to enhance your framing in your attic to support the new system. You'll also want to ensure that your roof is in good condition. You don't want to have to remove a fully functioning solar array to replace a failing roof. And there's a lot of debate about the visual impact of solar panels on a historic house. To mitigate the non-historic appearance of solar panels, you can try to avoid installing them on roof slopes that face the street. And that's going to depend a lot on the orientation of your house relative to the sun. You can also minimize solar panel visibility by making sure you have low-profile panels that are installed flush against the roof surface. and that the panels are oriented in the same direction and have kind of a uniform shape so that you don't get that Tetris configuration on your roof. More costly, more complex, and newer energy interventions, such as wrapping a house with several layers of rigid foam insulation and installing geothermal heating plants, get a lot of attention. In preservation terms, deep energy retrofits involve subjecting older and potentially historic homes to an unwarranted and unjustified level of experimentation in three critical areas: the material science, the building technology, and the construction trades. These highly engineered solutions require a high level of expertise on the part of the designers and installers of the systems. They're costly in dollars and in energy used to manufacture and install them. They have a lot of failure points, and they may not last long enough to pay for themselves. And it also includes, very often, a substantial loss of historic materials and finishes. That said, dramatic reductions in energy consumption can absolutely be achieved with these methods. But these retrofits are designed with new construction in mind. It's just like the building code. And an old house has very likely already shifted and moved and settled and sagged and been altered. So it's not easy to square that circle. We need a lot more information, more research on the building materials side, better understanding of historical methods and practices on the building technology side, and more training and specialized knowledge on the building trade side. Until then, the best advice I can give you with older houses is to keep your energy interventions at a more basic level. Respect the core preservation principle of reversibility and proceed slowly. If we can concentrate on enhancing energy performance in newer houses, we're going to develop the expertise needed to safely, successfully, effectively, and economically implement these strategies in older historic houses. We're just not there yet. So this all begs the question, do the conservation approaches that I've been recommending actually work? Well, in 2010, Historic New England put these concepts to the test in the building that I normally work in. This is the Lyman estate in Waltham, Massachusetts. It was constructed in 1793 with some major alterations in 1882 and again in 1917. In non-COVID times, it's used as offices and as a functions rental site. And the approach that Historic New England took was to focus on reversible changes, things that were accessible to homeowners, minimizing the harm to the architectural fabric of the house. And we actually set a target for ourselves of reducing our energy consumption by 50%. So how did we do it? Well, we used the exact same concepts that I've just been going over with you tonight. We started with baseline measurements and metrics, and we looked at air leakage, insulation, HVAC and utility improvements, and finally lighting. And this slide probably looks familiar to you. We started with an energy audit to identify areas to concentrate our weatherization efforts. And we also looked at how much oil we were using each year, 3,100 gallons, and how much electricity, 65,000 kilowatt hours. And then we got to work. So we started by repairing and weather stripping all 120 historic windows at the house. We added storm windows that we actually used 3 different kinds of storm windows in this project, depending on the location and the use of the spaces. We have exterior aluminum storm windows in some places that are set into the reveal of the window and custom color matched to the trim, so they're practically invisible. We have exterior wood storm windows in other locations, and those have swappable screens for the office folks. And we also have interior compression fit plexiglass windows in still other locations. Over time, the Lyman Estate house had a number of new penetrations for things like plumbing and data, and we sealed those with a reversible foam product. Unfortunately, that product is only available in Sweden at this point, but there are some other less reversible options available in the United States. It's really important to seal before adding blown-in insulation, or the insulation would frankly just fall through the ceiling and make a mess down below, in addition to being rather ineffective. In terms of insulation, at Lyman Estate, the attic and third story are not occupied spaces. They aren't spaces that we're using regularly for offices or anything. So we chose to insulate across a continual plane just above the second floor. And that isolated the third floor in the attic from the conditioned space in the rest of the house. And then we insulated by carefully taking up the floorboards and using blown-in cellulose in the cavities below. We also did a change in our fuel source to natural gas, and that allowed us to install a much more efficient furnace, 4 high-energy furnaces, actually, as well as air conditioning. And we shifted the whole control system over to digital controls that we can operate remotely. So be aware that if you install a high-energy furnace these days, it requires special venting, because the vapor that a high-energy furnace vents is very acidic and corrosive. So at the Lyman Estate, we chose to remove and store a cellar window and install these PVC periscopes out the back through that opening. We were able to screen them pretty well with plantings, and they can also be painted to match a foundation or the cladding of a house. The alternative to that is to vent through your chimney. And in that case, you have to line the chimney. It's really important that you do that, again, because of those corrosive gases. Poured in place liners are irreversible, and they can be really damaging to historic bricks. So stainless steel liners can be pulled through, and they're a much better option from a preservation standpoint. We also did a lot of work on the ducts throughout the house, bringing them up from the basement to service the first floor and down from the third floor to service the second floor. Along with this came a lot of air sealing, replacing poorly installed modern ductwork that have a lot of leaks, and of course, lots and lots of insulating. And then we also converted our historic light fixtures to LED bulbs. And remember, this was done in 2010. So today there are even more options for you in lighting to ensure a really nice result. And how did we do? Well, this project resulted in almost a 50% reduction in our energy usage, just like our goal laid out, all adhering to that primary objective to preserve the house. So not only was this a significant reduction in energy usage, actually our overall usage of the site increased after this project as a result of some of the publicity of our work here. However, you can see from the numbers that our energy efficiency decreased just a little bit over those first few years. And a lot of that has to do with the fact that the novelty of this project wore off with our staff, and our commitment to efficient practices decreased a little bit. And that's an important thing to remember. Because what are the big takeaways from all of this? Well, first off, old houses can absolutely be energy efficient, and making them more so may save them from unnecessary demolition later. Start with good maintenance practices, look for historic solutions and simple things that you can do yourself. Choose low-tech, well-researched interventions, prioritize reversibility, weigh the benefits and risks of standard solutions carefully, and finally, don't underestimate how behavior impacts the efficiency of our environment. And that brings me to the end of my presentation, and I think we'll open up the floor to questions. Lee, if you're ready.
Great, we are ready. So just a reminder, if anybody has any questions, you can type them in the Q&A icon at the bottom, and I will ask Carissa, and we'll get some of your questions answered. So the first one we have in is from Laura, and she says, in Vermont, they are starting to see insulation applied to the exterior of buildings, requiring the removal of siding and cornice, thereby losing the original materials and design profiles. Do you know of any studies that have been done to determine if exterior insulation is better than interior methods?
You know, I'm not familiar with a study in particular that weighs exterior versus interior insulation. And you're right that it poses all sorts of issues in terms of profiles and how trim meets up and just the overall appearance of a building. One of the places, though, that you might check is Building Science Corporation. It's a company out of Somerville, Massachusetts, and they do a lot of very kind of data-driven, science-driven study of how buildings function. They're not exclusively focused on old buildings, but it's a great resource in terms of understanding how some of these complicated systems work, and they may have some data that would help with that question.
Great. Another one which we might not know, have you heard anything about seaweed insulation? That's kind of a new one to me, but we have a question whether keep it, issues, any thoughts on it, if you're familiar with seaweed insulation?
Absolutely. Seaweed insulation was an insulation material that was used certainly through the early 20th century. We have some, I believe, some advertisements in our archival collection that talk about seaweed insulation. We also have seaweed insulation in some of our houses. The Pierce House being one of them. That was that house in Dorchester, the salt box profile that I had showed. So it certainly was used. We find it in houses from time to time now when we're working with homeowners. Have not come across any particular issues relative to it. But it is a fascinating kind of thing to find, and it was used, you know, kind of all over New England. New England seaboard.
So we have a couple questions related to air conditioning in historic houses. The first one is they have heard that a change in the internal environment can be a problem. And then the second person is asking about mini split systems.
Sure. So introducing air conditioning into a historic house is definitely something to consider carefully because it is going to shift kind of how the house functions. You may realize some benefits in terms of humidity control potentially, but it's something to really consider on a case-by-case basis. In all of the homes that we have worked with, private homeowners who've put in air conditioning, we've not seen any major issues come of it. You know, in a museum environment, it's something that we monitor much more carefully because we're concerned about humidity and moisture control relative to collections. But in terms of building systems and building function, I think you can introduce air conditioning relatively safely. It does absolutely change the dynamics if you have wall insulation and thinking about how moisture migrates through the walls and whether it's accumulating on your wall insulation. So that's just another reason to be very careful about considering insulating your walls and the possible risks and benefits to a project like that. In terms of mini split systems, those are a great option for old houses. They are fairly efficient, and they can also be a really good way of kind of supplementing a more traditional heating or cooling system. The nice thing about mini split systems is that they don't require you to install a lot of ductwork. A lot of it is about running lines on the outside of the house, and you can do that in careful ways, considered ways. And then there are exterior units that you'll have to consider placement of, the condenser units, and on the inside, then there's a kind of a wall-mounted unit that goes inside and can be carefully placed again. So mini splits are a great option. We recommend those along with mini duct systems if you're considering changing or adding heating or air conditioning to your house all the time.
Great. All right. Our next question that's come up is, do you have any suggestions on how to insulate stone wall foundations or stone foundations? I think this kind of comes back to that issue of basements and insulating basements and it being a challenging space, but any comments on that area?
Sure, sure. So to insulate a basement, the first thing you want to think about is moisture management and making sure that you've got that kind of under control. You don't want to insulate a basement that's going to get wet because you're just going to deal with a lot more issues at that point. But assuming that you have a well-maintained foundation and that you have moisture mitigation strategies in place, you can insulate a foundation wall. You can kind of build an additional wall inside of the basement and actually put rigid foam insulation over that structure. It's almost kind of building a box within your basement. You sacrifice a little bit of space in doing that. You sacrifice the visual of your foundation walls and the ability to monitor what's going on with those, which is an important thing to consider. And then it's worth doing an energy audit before you go to that length, because that's a big project to insulate your foundation walls. And it may not be the most necessary strategy. The most energy loss in basements tends to be in that space between the ground and your first floor, that little bit of exposed wall there, which is where I talked about insulating along the sill or along the rim joist, because that's where you're exposed. Otherwise, you're up against earth, which can actually add a certain amount of insulation in its own right on the outside of your house.
Great. So we have a number of questions that people are kind of asking about suggestions on interior storm windows, exterior storm windows, or more about those. I know on our website and our white papers, I believe we have our kind of case study that complemented the Lyman estate project that happened. Do you have any other comments to share? Most of them are just kind of looking for suggestions or a little bit more information about storm windows.
Sure, sure. So there's no such thing as a bad storm window. They're just more effective storm windows. Allied is a really great place to look if you're thinking about exterior storms. Allied storm windows tend to be really good quality. Inner Glass is the company that we worked with at the Lyman estate to get the interior storm windows, those compression fit interior storms. And those have also worked really well for us. We have some really big windows in our ballroom at the Lyman estate. And so we needed interior storms that we could take in and out that wouldn't weigh a ton, that we could manage as staff. And so they made us plexiglass interior storms that are really very manageable relative to their size, which is a great thing. The other company that makes really good interior storms is a company called Indo Window, which is based out of Oregon or Washington, I'm not sure, out in there, out in that region. But they make a similar kind of interior storm, but it has more of a gasket fit as opposed to that kind of compression fit. But in all cases, a storm window is going to help increase the efficiency of your windows by a significant margin. And it doesn't have to have a major impact in terms of the aesthetic quality of your home.
Great. Just looking through some more of the questions here that came up. And I know that was a number of people were asking about kind of storm windows, companies for storm windows. So just want to go through and see if we have anybody, another question to ask here. So one that comes back to one of your slides, you'd shown some houses that the insulation, the peel was sticking, paint was peeling, sorry. Do you have any suggestions for a house with cellulose insulation that was put in the exterior walls 40 years ago and the paint will not stick successfully on the outside? So they know there's moisture being created. Sorry, I guess they, if you want to comment on kind of insulation in walls and paint sticking, I think is where their question is going here.
Absolutely, absolutely. It's a frustrating problem. So I'm really sorry to whoever is asking this, because it's not a fun problem to have. Lee and I have been working with a homeowner who's been dealing with a similar issue. They just discovered a lot of blown-in insulation in their house that also appears to be a kind of 1970s comprehensive, very comprehensive insulation job that has gone quite awry now. You're always going to have a hard time getting paint to stick to a wet substrate, a damp substrate. So in a lot of ways, you're facing a big challenge. You can continue to repaint, right? You can do the very best paint prep possible, scraping down to bare wood and priming and following all of the guidance that we have in our white papers on our website, for example. And even then, you're still going to be looking at early paint failure if you haven't addressed the underlying moisture problems. And really the only way to do that is to get that wet insulation out of the wall cavities. And that is unfortunately not a fun job. It's going to involve removing a fair amount of the cladding or on the interior, some of that interior wall surface. If you're lucky, you'll be able to kind of vacuum that blown-in insulation out, but it depends on how packed in it's become. I would suggest going maybe elevation by elevation or room by room as you undertake this project, because it can be a real challenge. And if you're seeing issues with paint failure, you may very likely uncover additional issues underneath as you start to remove the cladding and take a look at the framing that's had moisture trapped against it all this time as well. So it's definitely something worth looking at and trying to get at that underlying problem, but just know that it's a big job. So trying to break it into manageable pieces is probably an important component relative to your own mental stamina for the project.
Great. Okay, so we have some more questions here, but for anybody whose question we didn't answer, or able to answer or haven't answered yet, if you can email the Preservation Services team at easements@historicnewengland.org. But so if you have any additional questions that you'd like to kind of reach out to our team with, but we are going to, I want to thank everyone for joining us tonight, and thank Carissa for taking the time to go through the presentation with us, and great information shared. So if you have any direct questions, you can definitely email us at that, and we will try and follow up if we can with everyone that had leftover questions here. So thank you.
Absolutely. Thank you everyone for coming tonight. It was really, really great to have you all with us.